In section 4.5, we're going to jump from equations to graphing inequalities. Now, if you remember, an inequality is something like x is greater than 2, x is less than or equal to 5, x is not equal to 10. So inequalities are not equal to, but either are greater than, less than, greater than or equal to, or less than or equal to. And if you remember from either 6th or 7th grade, that's when you would put an open dot, closed dot, and you would shade on a number line to the right or the left. It's the same idea, but now you're going to be using inequalities within linear inequalities. So you're actually going to be graphing on a coordinate plane using inequalities. So we're going to start with the gray box on page 263. It says that a linear inequality in two variables, such as y is greater than x minus 3, can be formed by replacing the equal sign in a linear equation with an inequality symbol. A solution of an inequality in two variables is an ordered pair that makes the inequality true. So any inequality that we plug in that makes the inequality true, that ordered pair is the solution. Your essential understanding: a linear inequality in two variables has an infinite number of solutions. These solutions can be represented in the coordinate plane as the set of all points on one side of the boundary line. So we'll understand and we'll go over what the boundary line is as well. So we're going to start with problem 1. In this section, we just want to know if the ordered pair is the solution. So in letter A, we want to know if 3, 6 is a solution of the inequality y is less than or equal to 2/3 x plus 4. All we do is plug it in. Y is 6 is less than or equal to, whoops, no equal sign. It's less than or equal to 2/3 times 3 plus 4. 6 is less than or equal to 2/3 times 3 is 2 plus 4. 6 is less than or equal to 6. 6 is equal to itself, so this is true. So is it a solution? Yes. And why? Because it makes the inequality true. So then B asks, suppose an ordered pair is not a solution of y is greater than or equal to x plus 10. Must it also be a solution, or must it be a solution of x plus 10? Well, let's think about it. Let's make an equation or an ordered pair that's not true for that inequality. So I'm going to say 5 is greater than or equal to 1 plus 10. Well, obviously 5 is not greater than 11. That ordered pair I plugged in that I made up was 1, 5. So now let's try to plug it into this next one. So 5 is less than 1 plus 10. Is that true? Is 5 less than 11? Yes. So must it be a solution? It doesn't necessarily have to be a solution. In this problem it was a solution. However, it could be on the line as well. And if it was on the line, it would not be a solution, which means it would be equal to 10. So we could have said y is 10 and x was 1. I'm sorry, let's do negative 1. Now in this problem, 10 is less than or equal to 9. That's not true. But we could also say that, let's say y was, let's say we had the point 0, 10. Well, if y was 10 and x was 0, 10 is less than or equal to itself. No, this would not work. And actually, 0, 10 wouldn't make any of those true. So therefore, it doesn't have to be a solution. It could be, but it's not going to always be a solution if it does not work for the original inequality. So in example 1, we have y is less than or equal to negative 2x plus 1. And we want to know if the ordered pair 2, 2 is a solution to this inequality. All we do is plug it in. 2 is less than or equal to negative 2 times 2 plus 1. So that would give you 2 is less than or equal to negative 4 plus 1. 2 is less than or equal to negative 3. Well, 2 is not less than or equal to negative 3. So no, this is not a solution. In problem number 2, we're going to start graphing an inequality in 2 variables. Now I want you to look at the shaded box on page 264. On page 264 it says, the graph of a linear inequality in 2 variables consists of all of the points in the coordinate plane that represent solutions. So everything that you shade is a solution to the inequality that you are going to graph. The graph is a region called a half plane that is bounded by a line. All the points on one side of the boundary line are solutions, while all the points on the other side are not. So the shaded region are your solutions, and the unshaded region would not be your solutions. So we're going to start with this inequality here. Y is less than or equal to 1/2 x plus 1. Now, when you are graphing the boundary line is when you are going to just graph it like a normal equation. So if you're going to graph it by a normal equation, I want you to pretend that it's just y equals 1/2 x plus 1. And you can graph it however you would like. Because it's in slope-intercept form, I would use slope and y-intercept. So we start with a y-intercept of 1, and our slope is 1/2, so we go up 1 over 2, up 1 over 2. Now, this is where you have to look at your shaded region. Anytime you have a less than or equal to, or a greater than or equal to, if it's equal to, it has to be a solid line. And this is the boundary line that you are drawing. The boundary line is either going to be dashed or solid. If you have an equal to, it's going to be solid. If it's less than or greater than with no equal to, it's going to be dashed. So because up here that this one is less than or equal to, you're going to draw a solid line. Now, here's the tricky part. You have to determine which part of this line are solutions. Everything above the line is going to be shaded, or everything below the line. So here's how you do it. Pick any point that is not on the boundary line. Any point you want. The easiest point to always pick is 0, 0. So you're going to take the 0, 0, and you're going to plug it in to the original inequality. So that would give you 0 is less than or equal to 1/2 of 0 plus 1. 0 is less than or equal to 1/2 times 0 plus 1. So that's 0 plus 1, which is 1. Is 0 less than or equal to 1? Yes. That means this point right here that you graphed, that you plugged in, this is a true side, and that's the side you want to graph. So we are going to graph, or shade, the true side. If you ended up plugging in 0, 0 and it was false, you would grade everything above. So this is the region that is less than or equal to the boundary line. So everything that's on the line and below it would be your solution.
Hi, Hannah.
Jayla saying hi. Hi, guys. How you guys doing?
So on example number 4, we're going to skip 3. Number 4 says y is less than negative 4x minus 1. So once again, we're going to graph the boundary line. Treat it just like an equation. So negative 1 is our y-intercept. Our slope is negative 4 over 1, so that means I go down 4, to the right 1, down 4, to the right 1. Now, because this is a less than, that means it's not equal to, so everything on the boundary line is not a solution. So we draw that representing a dashed line or a dotted line. So that is your line. Now, we need to pick a point not on the line. So I'm going to pick 0, 0 again. So I'm going to plug in 0, 0. So 0 is less than 0 minus 1. 0 is less than 1, or negative 1. 0 is not less than negative 1, so this is false. So that means the side with 0, 0, which is above this, is the false side. And I need to shade everything that's true. So that means I would shade everything to the left of that line. So once again, to determine what side you shade, you have to shade the true side. You plug in a point not on the line, and then if it's true, that's the side you shade. If it's false, that's the side you don't shade. In problem 3, we're now going to graph a linear inequality in one variable. Now these boundary lines are easy because these are either going to be horizontal or vertical lines. So once again, let's look at A. A is x is less than or equal to negative 5. So we're just going to graph like x equals 5, negative 5. So that means we're going to have a vertical line through negative 5. However, since it's a less than, it's going to be a dotted line. So we have a dotted line. Now here, to figure out where you shade, you don't need to even use to plug anything in because it's x is less than 5. Well, the numbers to the right get bigger, the numbers to the left get smaller. So because it's less than 5, that would be everything to the left because those numbers get smaller than negative 5. In part B, y is less than or equal to 2, we're going to have a horizontal line through 2 on the y-axis. Because it's less than or equal to, it's a solid boundary line. And because it says less than, everything underneath this line would be shaded. And that would be your line. That's all you'll have to do to graph a vertical or horizontal inequality. In the gray region on the top of page 266, it also gives you another way to determine where to shade. When a linear inequality is solved for y, that's important, it has to be solved for y. The direction of the inequality symbol determines which side of the boundary line to shade. If the symbol is a less than or a less than equal to, you're going to shade below the boundary line. If the symbol is greater than or equal to, you're going to shade above the boundary line. Sometimes you must first solve an inequality for y before using the method described above to determine where to shade. Alright, for this section, you actually have word problems that you first have to write an inequality for, and then you graph them. So it says, for a party, you can spend no more than $12 on nuts. Peanuts cost $2 per pound. Cashews cost $4 per pound. What are 3 possible combinations of peanuts and cashews you can buy? So we know, let's let peanuts be P, no, let X. Let's do X as peanuts. And Y as cashews. We know peanuts cost $2 a pound, and cashews cost $4 a pound. What are 3 possible combinations of peanuts and cashews you can buy? So we have to spend no more than $12 on nuts. That means you can spend $12, but we can't go over it. So our inequality has to be less than or equal to 12. Now you can graph this using intercepts. That's completely okay. But I'm going to solve this for y. So I'm going to move the x to the other side, negative 2x plus 12, and then I'm going to divide everything by 4. So that would be negative 1/2 x plus 3. And then if I graph it, I have 3 right here, and down 1 over 2, down 1 over 2. Now, because I can't have negative peanuts and cashews, you're not going to have arrows on either side. So, here is what my graph would look like. Now we have to shade. Well, because we're shading, it says right here, less than, that could be the region anywhere underneath this line. But remember, I can't have negatives, so I can't have anything in this section here, quadrants 2, 3, or 4. So my shading would actually be anything in here as well. So remember, you're not going to spend exactly $12. You could spend up to $12. So any possible combinations would work. So you could say 1 pound of peanuts and 1 pound of cashews, because 1's right here in the shaded region. Anything in the shaded region would work. So you could say 1 thing of cashews, 1 thing of peanuts. You could say 2. That's solid. So that is also a solution. You could say 4-1. You could say 3-1. You could say 2-1. You could say 1-1. You could say 1-2. So any of these would work in this red shaded region or on the line. All right, on number 7, it says, you budget $200 for wooden planks for outdoor furniture. Cedar costs $2.50 per foot, and pine costs $1.75 per foot. So we know I'm going to let cedar be X, so $2.50 per foot, plus $1.75 per foot of pine, that's Y. you have to budget $200. That means you can spend $200 or less. So if we graph this, I'm just going to graph using intercepts. So if you graph this, the x-intercept is going to be 200 divided by, so your x-intercept, 200 divided by 2.5 would be 80. And your y-intercept, which would be 200 divided by 1.75, would give you, actually, if you divide that, you don't get an even number. But you can't have 0.3 feet, so we're just going to say 114. Or you can say 115 if you wanted to round up, since you would actually need a little more. So now, if we graph this, you would graph it only in the first quadrant. Now, x is your cedar, y is your pine, and x would be 80, so I'm going to count by, let's do tens. 10, 20, 30, 40, 50, 60, 70, 80. Your y-intercept is 114. I'll count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 110, 120. So 114 is about right here. Now, because it's less than and equal to, you'd have a solid line. Anything on the line is a solution. You wouldn't graph anything below or left of the axes because those are negatives. And we do not want to go over $200. So if we don't want to go over $200, it'd be everything underneath the line. So anything here would work. So the question asks, what are 3 possible amounts? You can pick any values that are on that line or anything less than in this red shaded region. And that's your answer. Whatever you choose, as long as it's in the red region, would work. In the last section, we're going to actually write an inequality from a graph. So if we look at the got it problem says that we are writing an inequality from a graph. The boundary line is dashed and has a slope of 1/3 and a y-intercept of -2. Well, let's start with that, the slope and the y-intercept. So we know we have a y, and we have a 1/3, which is our slope, so that'd be 1/3 x, y-intercept of -2. And because it's dashed, we're not going to have an equals to. And we know that since the shaded region is above the line, that it's going to be greater than. So we know it's going to be y is greater than 1/3 x minus 2. Number 9, we have a graph. So in number 9, we first have to find the slope and y-intercept. Now we've done this last chapter, so this shouldn't be difficult. Well, the y-intercept crosses right here at 3. I'm going to put that in green. Right here at 3, so we know the y-intercept is 3. We know our slope goes downhill, so it's going to be negative. So let's pick another point. We have a point right here. So what do? Well, I would go down 3 over 1. Down 3 over 1 would be -3 over 1, which is just -3. So we know my equation, or my inequality, will be y. And then it'll be -3x plus 3. Because it's a boundary line, the boundary line is solid, it's going to be an equal to. And because we're kind of shading up above the graph, it's going to be greater than. So my inequality would be y is greater than or equal to -3x plus 3. Now the last one I want you to do on your own. If you want to pause the video, you can. But I'm going to explain it. On number 10, we have a y-intercept of -3. So at the end of my inequality, I will have a -3. My slope from that point would go up 3 over 2. That gives me a slope of 3/2 x. And then -3 with my y-intercept. Because it's dashed, I would not have an equal to. And because it's above the line, my inequality would be greater than. So my inequality would be y is greater than 3/2 x minus 3.